Hi, I'm Pablo Urcid at Cisco with the Data Center Networking team. To begin, I would like to ask a question. What is the first thing that comes in mind when you hear the word multi-cloud? Is it a trend? Does it accelerate innovation and productivity?
Well, all of those are true. However,
Have you thought how hard it is to maintain in a multi-cloud architecture business continuity and minimize downtime, increase resiliency? The more clouds, data centers, and collocations you manage, the harder it gets to achieve consistency and monitoring from a single pane of glass. All of these things may disencourage you to implement a multi-cloud environment
and adopt the benefits the architecture may give you. But don't worry, we have a solution. It is called Cloud Network Controller.
Actually, it used to be called Cloud ACI. So if you want to get more in depth about the solution, you may watch previous videos in this channel. Now, let's continue and have a quick overview. Cloud Network Controller is a software instance running on the cloud service provider that would automate the network construct of each vendor and connection between them. As a result, the network and applications team would have a single operational model that allows them to build a resilient framework that enhances their innovations, hence that a greater user experience. How do we achieve this? Clouds have proprietary architecture in their network, so this complicates management and coexistence between them. With Nexus Dashboard and Cloud Network Controller, you can create consistent configurations across sites, clouds with a deploy once and single policy model. Now that we know the benefits of the controller, let's put it into practice with a real use case. The scenario we would be working is cloud only, but keep in mind, Cloud Network Controller can also extend policies with ACI and NXOS devices. Let's see how the topology for the demo is built in order to achieve business continuity between clouds. For this exercise, the user petition would be directed to the virtual address of a load balancer and redirected to AWS server with the application, in this case, a web app. The balancer is a key component to failover the traffic to the next available server. In this case, the node is located in Azure. But remember, having Cloud Network Controller and Nexus Dashboard allows us to automate the interconnection between clouds and avoid manual configurations that would put at risk our resiliency. For this contingency plan, we are going to simulate an outage in AWS and automatically steer the traffic to Azure available node with the app. For the user, this is going to be transparent and automated. You want to see how it looks? Follow me. First, let's test connectivity between Azure and AWS machines with the app. Let's open Azure VM and review its details. Now, let's do the same for AWS. Now, we have both internal IPs of the nodes. We are now testing connectivity from Azure to AWS and vice versa. It looks successful. Let's keep a continuous ping from AWS to Azure to validate controller is managing the policies and communication between clouds. Now that everything looks okay, let's log into AWS and review the security groups our application VM has. They are the ones enabling communication from and to the machine. Our next step is to log in into Nexus Dashboard, which is controlling Cloud Network Controller policies. We're just going to remove the ability on AWS to communicate to Azure. We apply and we wait for the configuration to sync. After this change, we return to AWS console and review the policies just by refreshing the security group object. Derived of the policy change on Nexus Dashboard through Cloud Network Controller, AWS security groups adjusted automatically. So what is going to happen to our continuous ping?
communication broke. That is the expected result. Let's return to Nexus Dashboard and reinstate the policies and reapply. communication should restart momentarily. Security groups were changed again by Orchestrator and Cloud Network Controller. Due to those changes, communication restarts, and ping goes back to normal. So let's go and take a look at the application, which is our main use case. To do that, we get the IP address of the service load balancer and access it. We have to check if the balancer is having connectivity to the nodes in Azure and AWS, which are hosting our application. As you can see, the load balancer is connecting via the internal IPs of the VMs, which are available through Cloud Network Controller. Now, I'm opening a new browser and accessing the application. As you can see, AWS was the server to answer the petition. We are now going to simulate an outage in AWS by removing the interconnection policies between the service load balancer and AWS instance. We proceed to validate on the balancer and it lost connection to AWS EC2 instance. How do we validate continuity of our operation? Simple. We just refresh the browser without changing the IP. Now, Azure server answers the petition. Pretty cool, huh? Well, that proves Cloud Network Controller was the solution that enabled connectivity between clouds and allowed us to maintain operation in the outage. Do you like it and want to learn how to configure it? Let's enumerate the building blocks of the solution. First, we would deploy from each marketplace a Cloud Network Controller. The process is automated. Once configured, the controller automates the creation of CAT 8000V instances that would interconnect both clouds. As part of the exercise, we will also deploy Nexus Dashboard and Orchestrator, then connect each Cloud Network Controller to achieve a single point of management and automation. By doing this, we automate the creation of objects in each cloud. Just a note, in the case of AWS, we would require 2 accounts to achieve our configuration. That is how they architected their infrastructure with Transit Gateway. Well, that was a lot of information. Let's break it into pieces. The next videos will show in detail everything step by step. In the first video, we would deploy Cloud Network Controller on Azure. Then we would do the same but for AWS. In the third part, we will deploy Nexus Dashboard on vSphere, install Orchestrator, and configure multi-site between the clouds. And finally, we are going to get all together and configure the business continuity use case. With these simple steps, we can achieve business resiliency and enhance user experience. As a result, this would allow us to accelerate digital transformation. Stay tuned for the next videos.